So welcome everybody to 7.3 and 7.4. So we're going to be looking at how to solve right angle triangles, and specifically we're going to be looking at finding side lengths. So to start, trigonometry, which is what this comes from, is dealing with the relationship between sides and angles. So remember in the previous video we were looking at Pythagorean theorem where we were only finding side lengths. Well, now, like your lucky day, we get to look at the relationship between sides and angles. So if you've ever seen on your calculator these buttons right here, sine, cos, and tan. This is what we're going to be working with. These are the three ratios. So the function is called sine, cosine, and tangent. And these are the following short forms that go with it. So hopefully we can go through this quickly. We've got 12 slides to get through. So in the right triangle, we can relate the angles with the side lengths using these ratios. Now, we usually represent an angle with a symbol called theta. So when you draw it, you make a circle, and then you come back through the middle. So this is called theta. It's a Greek letter that we use for angles. Based on the given angle that you're going to have, and in this case you will be given the angle theta, you must be able to label your hypotenuse, your opposite, and your adjacent. So we're going to go through an example of how we would do that. So in this example, because this is your theta here, this is your angle that we're talking about, we have to figure out which one is the opposite, which one is the adjacent, and which one's the hypotenuse. The opposite is always the side length that is across from the angle. So if you put your finger right here, the only side that you are not touching is this side. So that must be the opposite. The other one that's really easy is the hypotenuse. Because you can see your right angle, if you go across from your right angle, this is always the hypotenuse. So that one's also easy. And this leaves the remaining, which is the adjacent. The adjacent is always the angle, or the side length, sorry, that is beside the angle. So see how it's not the hypotenuse, but it's beside your theta. We'll do another one. What if the angle is here, and we are to label the opposite, the adjacent, and the hypotenuse, which we can use short form O, A, and H. The H, again, is easy. It's across from the 90 degree. O, if you were to put your finger on your paper where the angle is, the only side length that you are not touching is right here. And so this one would be the O, and then the remaining one is the A. And if you have any questions about that, please make sure you write that down. And so we actually have a short form that we can use using these letters, and this is called SOHCAHTOA. So you will need to memorize this. It is the easiest way to learn how to do the trigonometric ratios, and here is what they are. So what the SO part means is right here. So this is the SO. This is the sine equals the opposite over the hypotenuse. So we have sine here equals the opposite over the hypotenuse. And notice that sine will always have the angle with it. The next one is the SOHCAHTOA. So we're at the ka part now. This is the cosine here equals the adjacent over the hypotenuse. So notice where these letters are coming from. The cosine equals the adjacent over the hypotenuse, which we just learned how to label those. And again, it's cosine of an angle. Every trig, sine, cos, and tan will always have an angle that goes with it. For tan, we have, this is the TOA part. We have tan equals opposite over adjacent. Notice again, tan equals opposite over adjacent. So these are different things that you can substitute in. Opposite, adjacent, or the angle. The tan is the button on your calculator. So as long as you can remember SOHCAHTOA and how those each of those components should be written, you should be good to go. So we're going to look at a calculator. The first thing I'm going to bring up here in a calculator, no matter where your calculator, what it looks like, this part here, in this calculator it's saying R-A-D. You do not want it to say R-E-D. You either want it to have a D or a D-E-G. You need your calculator to be in degrees right now. Not until later years you'll actually put it in R-A-D. So make sure it's in degrees before you do any of your calculations. So in here you can see that we have sine, cos, and tan. So these are the buttons that we're going to be using on the calculator today. So what I want you to do is I want you to see if you can actually solve for this. So you're going to push tan and then the numbers 60 and then enter. Some calculators might be backwards. You might have to push 60 and then tan, and then it will give you a number, and see what you get with that. So these are the values that you should have got when you typed in tan 60, sine 60, and cos 60. And so hopefully you can check that. And if you have any problems with it, then make sure you write those down and bring them to class. Now we're going to look at an actual triangle and some side lengths that are given. So we're going to find 3 primary trig ratios for angle A. So the first thing that you're going to need to do is identify where angle A is right here. Okay, so this would be our theta. If this is our theta, we would then have to be able to label O, A, and H. So O is always opposite to the angle, H is always the longest across from the hypotenuse, and A is always the remaining one or the adjacent, which is beside. So if we were to label the 3 primary trig ratios, this is your SO, your CA, and your TOA. So we're going to actually have to fill in those formulas that we wrote in the previous one. So this one, sine theta equals, it's going to be your O over H. So if we rewrite this, sine theta, what was our O? Our O was 10. Our H was 26. The cos is cos theta equals adjacent over hypotenuse. Adjacent was 24. Hypotenuse was 26. Tan. Tan theta equals opposite over adjacent. Opposite was 10 and adjacent was 24. And again, these can be reduced and these can also be all turned into decimal form. So now we're actually going to be solving for a side length. So we're going to solve for this unknown side length here. And to start, again, remember, you always want to label your O, your A, and your H. Now, these can only be labeled based on an angle. So in this question, we are given this angle. So if we're ever finding a side length, you will always be given one of the angles, or you might have to do some calculations to solve one of the angles, but we have this one, which is 32. Based on this angle, if we label O, A, and H, H is always across from the hypotenuse, O is always across from the angle, and your remaining one is A. So now the whole part that is tricky is to figure out, well, which one do we use? Do we use SO, do we use CA, or do we use TOA? Every question will be different. So in this question, we are trying to solve for x. X is O, so we know we're going to have to include O somewhere. This gets rid of the CA part. There's no O in the CA. The other thing we have to look at is which one are we given? And in this question, we are given the A. So this one here, the SO, it does not have an A. So the only option left is the TOA. So we're going to have tan of our angle equals O over A. And if we start to substitute values in, we have tan of our angle, which is 32 degrees, equals O, O is x in this question, over A, which is 13. Now, if we're trying to isolate for x here, we're dividing by 13. So if we take divided by 13 to the other side, we're going to have times it by 13, which is tan 32 degrees. And if you just type that into your calculator to get your answer, 13 times tan 32, you will get 8.1233. And we are asked to nearest tenth, so x equals approximately 8.1. So the last example here, we're going to solve again another side length. So first start by labeling your O, A, and H. Based on the given angle of 37, our O is across here, our hypotenuse is across here, and our adjacent is the leftover one. So looking at this one, again, we have to figure out which one of these, SO, CA, TOA, are we going to use. So we know we're looking for x, so H has to be somewhere in it. So tan is not an option. There's only an O and an A here. The other option that we need is we don't know anything about this O, so we're not going to be using O. What we do need is this 11. This 11 is our A. So notice that sine, it doesn't have an A, so sine we cannot use. So the CA part is what we're going to use. This is cos of an angle equals A over H. If we substitute in values, we have cos of 37 equals 11 over x. Now, if we have to solve for x, x cannot be in the denominator. So this divided by x, if we bring it to the other side, we're going to times it by x. So we're going to have x times cos 37. Now, you can put brackets around the 37. It's not necessary. It's always known that cos takes an angle. So we multiplied this x over, but again, we're trying to get x by itself. So we have to divide by cos 37 to bring it to the other side, because that's the opposite operation of what we're doing. We have x times cos 37. So x equals 11 over cos 37. And if you type this into your calculator, you're going to get that x is approximately 13.8, and we don't have units, so we would just leave it as is. If you have any questions, please make sure you write them down and you can bring them to class.